Okay, so going to go through electrolysis, and we're going to use the WJC Science Double Award module that's installed on GCSEtutor.ai. So within any subject, you have the ability to go through and have a lesson on every line in the syllabus. You can revise your mind maps and flashcards that you would have created from those lessons. They're created based on the actual content of your lesson and the bits that you're struggling on, or you can practice exam questions and you can check your progress. So on here you can go and browse all the topics in the specification, or you can have the AI recommend what you're due to learn next, or in this case I can't be bothered to go off and find it. I'm just going to type electrolysis and it will go off and look through the learning objectives of the specification and bring back the best ones. So in this case we're going to do electrolysis of molten ionic compounds. Now ideally you should do the pre-lesson test, then do one of the lessons, and then do the post-lesson test. We're going to dive straight into the chat lesson for this, and I'm going to pretend, act as though I really know nothing about this subject, so let's really start from basics. Now I've got the text-to-speech off, and that doesn't stop me from chatting to the tutor by clicking on that button, or I can type. So today we're going to learn about what happens when we use electricity to split a molten ionic compound like lead-2 bromide. To start off, can you tell me anything you know about electrolysis or what happens when we melt an ionic compound? I really don't understand this topic very well at all. You just start right from the beginning for me, please. So the first time it runs on any lesson, the AI, or most lessons, the tutor goes off and looks for a drawing that it's created, and in this case it has, so no problem. We'll start simple. When a compound like lead-2 bromide is melted, do you think its tiny particles are neutral atoms or charged ions? And what's the picture it's got? Okay, it's got the process of electrolysis here. Probably a bit complex for me at this point because I don't understand what I'm looking at, so we'll come back to that. But to answer its question, I mean, I'm guessing charged ions because you're talking about an ionic compound, but I don't really know what that means. So let's see what it makes of that. Also, it's looking for helpful models. So they're interactive models. You don't have to look at them, but you can. You can also access a full suite of them at any point through here. But the AI knows about these interactive models and can bring you the most relevant one at the time. So let's start. Let's see. Great start. In molten PbR2, the particles are charged, Pb2 plus and Br minus. Which do you think is positive and which is negative? Okay. I mean, it's kind of showing me there. So it's really, I've asked it to be very sort of starting from basics. Let's have a look in there. So here's a metallic structure, nice, ionic, lattice and covalent structures with shared electrons, and start of a thing of diamond. What's advanced about it? Oh, like advanced materials. Okay. So it's showing me difference, I guess, between covalent and ionic. Great start. Okay, so, well, it looks like the lead is 2 plus and the Br is minus, so that tells you the charges. I'm not sure why they've got those charges though, or what that's got to do with electrolysis whatsoever. So you can see you can be fairly sort of clear with the AI tutor as to what you know and what you don't know. Fairly blunt with it. It's brought the diagram back. Nice, spot on with charges. Yeah, positive and Br, negative. Look at the diagram. The negative cathode attracts positives and the positive anode attracts negatives. Okay. That's the link to electrolysis. The ions move to electrodes. Okay. Quick check. In molten PbBr2, which ion will move to the cathode? I mean, obviously the positive one, so the lead, but before we get to that, like, can you explain to me why lead is 2 plus and why Br has got 1 negative? I think if I understand that, it will help me understand electrolysis. So, yeah, good question, simple idea. Atoms try to get a full outer shell. Bromine has 7 outer electrons. It needs 1 more to make 8. So it gains 1 electron, becomes Br minus. Okay. Lead, in lead 2 bromide, loses 2 outer electrons to get stable, becomes Pb2 plus. So in PbBr2, 1 lead gives away 2 electrons. Okay, and 2 bromides each take 1 electron. That's why it's PbBr2. Does that make sense so far? Yes, that makes sense. So you're saying that when you then put it into the liquid, they like become their ions again. Exactly. So when PbR2 is molten, it splits into free moving ions. Okay, so they're free to move around. Looking at the diagram, what do you think happens to Bb2 plus when it reaches the negative cathode? Let's go back up to the diagram. It's kind of telling you here, so it's gone to the cathode and it's gaining electrons, presumably from the cathode rather than from anywhere else. So, and it's making actual lead, not the iron. So let's say that to it. So looking at the diagram, it seems to be getting 2 electrons, not electrodes, from the cathode, and then it's forming actual lead. I don't know where it's getting its electrons from though. Is it from the cathode, and if so, how? Like, why is that cathode negative, and why is the other one, the anode, positive? Chatted quite a bit at it there. Let's see what it comes up with. It's having a think, so it's probably going to be grabbing something. There we are. It's looking at grabbing that diagram again. It's just useful because it means you don't need to keep scrolling up to see it. Great observations. Okay, short answers. The cathode is connected to the negative terminal of the power supply, so it has extra electrons. Okay, those electrons flow through the wire into the cathode surface. Okay. So the lead ions, the positive ions, gain 2 electrons at the cathode, and this is reduction. The anode is connected to the positive terminal, so electrons are pulled away there. As you can see in the diagram, lead metal forms at the cathode. So can you tell me what happens to the Br, or the bromide ions, at the positive anode? Let's have a look. So you've got the bromide ions in the liquid, and I guess it's the anode is providing a platform on which the bromide can give the electrons away as it's losing them, and that's saying that's oxidation, and in losing them forms the actual gas, which is the brown circles here, so you'll see bubbling. So it looks to me like the bromide ion is able to give away its electron to the anode, but obviously it's then unstable, is it? So it needs to combine with something else, and so it finds another bromide ion in a similar predicament, similar situation, and so they form bromine, so gas. You can see it bubbling on the picture. At the anode, each bromide ion loses an electron, then 2 neutral bromine atoms pair to make the gas. So anode equation is that, cathode equation is that overall. One quick check, which process is at the cathode? So cathode is the negative one, and the cathode is giving electrons to the lead, so that is here, so it's reduction, so it reduces. I guess I always think it's on 2 plus and it reduces it to nothing because you're giving it the negative electron, so it's reducing how positive that is. Let's answer that. So at the cathode, well, the cathode is negative, and so it's giving electrons to whatever the ion is. So it's reducing that ion's charge to neutral, so it's reduction. Let's see what it makes of that answer. Perfect. Okay, so when you get through the chat, about 17 messages through, it gives you a little check of where you are in the lesson. Excellent progress so far, clearly understood. Thank you. You've also correctly identified the electrode reactions and confident use of terms oxidation. Okay, still need to explore 2 key areas. One is how these ideas are used in the real world, for example, the role of electrolysis in metal extraction. The second is applying what you've learned to a numerical problem. Okay, so we'll continue. So it's testing me again. Which word describes bromide losing electrons? So it's being oxidized, isn't it, when you lose electrons? That'll be oxidation. One thing it hasn't told me, you now write the 2 half equations. Okay. One thing I want to understand is what is the liquid that you're putting that lead and bromine, or the lead bromide, into? Like, why does it become molten? Is it just water, or is it some special stuff? See what it says. Great question. For molten lead 2 bromide, the liquid in the is the compound itself. Ah, heated until it melts. Oh, it's not in water. Okay, I thought you dissolved it. See, I haven't done chemistry for a while. We heat solid lead bromide until it becomes a liquid. Ah. In molten PBr2, ions are free to move. Right. We avoid water because water would react and give hydrogen and oxygen instead. Yes. Yeah, that clears it up. Have you got a model, interactive model I can use to have a look at this in a bit more detail? Just click this one, as I think about that. So there we go. So I knew that existed already. I'm being lazy because you could go in here and I'd go to chemistry, and you've got all sorts of interactive models here. So what the AI tutor is doing, it knows about these, and so instead of having to have you find it in here, it pulls out the most relevant models. So metals and extraction. So we've got metal reactivity series, metal ores and extraction, blast furnace, electrolysis lab. So we've got actually lead 2 bromide here. So let's start electrolysis. So, right, okay, so the voltage is going up. We've created bubbles here of bromine. It's got the equations that I needed to use, and yeah, okay, I think I get it. I'm pretty certain I get electrolysis now. So something I did know a little bit about it before, having gone through GCSEs and A-levels, but I had forgotten that it is actually molten. You don't dissolve it in something else. I was just going to clarify that. So electrolysis is the case where you always melt the compound, the ionic compound. You never mix it with any kind of solution. Is that right? Or can it sometimes be that you do use some sort of solution? Let's see. I'd like to clarify that one. Bum, bum, bum. Click, click, click. Good thinking. You can do electrolysis of either molten ionic compounds like molten PBr2 or aqueous solutions. Okay, so you can use it. Ions dissolved in water. In solutions, water can also react, so products may be different. Okay. So quick check for molten P, so it's just double checking. Right, okay. So I'm happy with that. I'm not going to, we've gone through those equations, you don't need to see me writing those. Anytime you think, well, when the AI thinks you're kind of getting there, you can have a quick check and it runs the progress check again. If it thinks you have finished, this actually becomes easier to click, but I can click it. What I'm going to do is test my knowledge. So obviously I didn't do the pre-lesson test, but let's have a go at the post-lesson test, see if we can apply the principles that we've learnt. Had I done the pre-lesson test, this post-lesson test would have loaded instantly, but it's writing it from scratch at this point. Pop, pop, pop. Okay, so what happens to lead ions during electrolysis of molten lead 2? So we know they are reduced, so it can't be oxidized. They obviously don't gain electrons to form bromine. They gain electrons to form lead atoms at the cathode. Yes, and the cathode is the one giving the electrons away, isn't it? It's charity. Okay, which of the following electrode equations correctly represents the reaction at the anode? Okay, so that's where so anode is positive and the bromide ions are losing the electrons. So it has to have, yeah, and it needs two of them. So it needs two bromide ions to make the bromine gas. So it's that one, isn't it? Okay. What is the role of the cathode in the electrolysis of molten ionic compounds? The cathodes are releasing electrodes into it. That's what we learned. Why must lead 2 bromide be molten for electrolysis to occur? Because it's easier to handle, so the ions are free to move. Yeah, so of course they're carrying the current, so it's almost like wire, but it's a liquid instead of a wire connecting the circuit. Yeah, okay. What is the oxidation state change for lead during the electrolysis of molten PbBr2? So it's going from +2, it's being reduced, isn't it? It's going from 2 to 0. Which statement best describes what happens to the bromide ions during electrolysis? So they're losing electrons, they move to the anode and lose electrons. Yes, they don't stay in the middle, they don't turn into lead, they move to the cathode. No, they're doing that, they're losing electrons. So everything's trying to get to 0 basically, either by losing electrons or by gaining them. In the electrolysis of molten PbR2, which gas is released at the anode? Bromine gas. True or false? Electrolysis of molten PbR2 causes the Pb2 plus ions to move towards the cathode. Yeah, the cathode's negative. Yeah, so it's just driving home the principles. True or false? Bromide ions are reduced. No, because reduced means the number gets lower. They don't go from 1 minus to 2 minus, they go from 1 minus up to 0, don't they? So that's false. Describe what happens during the electrolysis of molten lead 2 bromide. Be sure to include what happens at each electrode and the chemical changes involved. Okay, so the lead ions have a charge of 2 plus. Oops. They therefore, I probably should put the ability to speak this bit, shouldn't I? But anyway, they therefore move to the negative cathode that we learnt. They gain electrons from the cathode to form stable lead atoms. Lead, so it's like metal, lead is formed. Then we'll say for bromide ions have a charge of 1 minus. I never understood why it's not -1, but that's just what happens in chemistry. Bromide ions have a charge of 1 minus. They therefore move to the positive anode. They give their electron to the anode. 2 bromide ions in this state therefore form bromine gas to ensure their outer shells are still full. Use the parenthesis. Okay, let's go. Let's see what we get. I thought that's a reasonable 8.7. Okay, got that right. Right. Hang on, what's the role of the cathode? It releases electrons into the compound. Okay. It attracts positive ions and reduces them. Yeah, okay. Strictly speaking, stronger answer, isn't it? Everything else nailed on. You'll always, in the free text, you'll always get like a model answer. So I've got penalised like 0.3. So what does it say? During the electrolysis of molten 2-bromide, the compound is heated until it's liquid. Okay, so it's giving a better description of the actual process as well, rather than just the movement of the ions, which is what I focused on, I guess. So the cathode, positive, and the anode. So it gave me like 0.7 for that. So thanks. So I got one wrong, and then it took 0.3 off for my answer because I could have talked a little bit more about it. Okay, well, that's 20 minutes on electrolysis that you'll never get back, but I hope it's been helpful. Hope it's shown you how the lessons work. Oh, I can create flashcards as well. Let's do that. You don't see the flashcards here, you just hit create, and let's create a mind map as well. If you can bear to stay, you can see the mind map's a little bit more complex. Okay, so let's go back here. I'll just quickly show you the mind maps. So flashcards, so electrolysis, here we go. It's one we've just built. So you can just literally just look at them and go through them. You can quick flip cards, so when reveal the last bit that's hidden of the text, and you can create a quiz from the flashcards themselves. So it's using all the bits from your lesson. I'm not going to obviously go through that. We've just done a quiz. The mind maps are, if they work for you, they're nice. When you first go onto it, it needs a little bit of editing. So if you switch to edit mode, you can see the main parent here. You can just divide it into sections that you like, that make sense. So and you can obviously save it once you've rearranged it. Here, and that one is there. Put that over there. So yeah, it's got quite a... So yeah, if you just look at this, for example, we can color code it as well. So if I select, I'm on electrode at the moment, and give it a style, let's apply to all child. Let's make it all like that color. That's cool, so I can look at electrodes there. Ion formation changes, so we've got the BR- and the PB2+, so let's give that a different color as well. Oops, I forgot to say all children. Let's do it again. Style, click that, and then we'll do that. What's this saying? Molten ionic compounds, definition, example, okay, yeah. And you can edit as well, so definition, like say melt to move. That makes more sense to me. So I learned that you have to melt it first, although some can go in water. Applications, molten versus aqueous, section, reactions and equations, cathode equation, overall. So look, you might want to write a cathode equation. So let's add a child, and you can write, cathode was negative, wasn't it? So lead PB2+, I haven't got superscript here, plus 2E minus goes to PB, like that. Cool, and I've got that as a child there. Let's create a different style for them, apply it to all, and there we go. Now if you hit save, when you go to study it, it's kept it, it's remembered the whole thing. You can collapse everything, start to expand the child nodes, and just try and remember what's there. Electrodes, so cathode and anode for electrodes. attraction of Pb2+, and it's the reduction reaction. For the anode, it'll be attraction of Br-, and it's the oxidation reaction. Cool. Okay, so that's how mind maps work. Great. Well, we've got to 25 minutes now of electrolysis, but for me that does, obviously I did know a little bit, having gone through A-levels and GCSEs, albeit years ago, so I have remembered some bits but not others. You can see that, if you tell the AI tutor that I just don't know this, keep asking it, keep challenging it, and you'll get the answers that you need, or the explanation for you to understand it. So I don't feel like I've come away from that lesson having to just remember tons of stuff. I've got concepts that I feel I could apply to different questions, because now I know what the anode is, I know what the cathode is, I know what the reduction reaction is, I know what the oxidation reaction is. I think that really does clear it up. So yeah, hopefully it's been helpful. Cheers.